To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.
Hello and welcome to A Theory of Everything. Today we're talking to Connor Leahy, a prominent figure in the field of artificial intelligence. Leahy is the CEO of Conjecture and is at the forefront of efforts to ensure that AI doesn't kill the human species. This is not as crazy as it sounds. Virtually every major personality and expert on this topic has acknowledged that the probability of AI ending human life is non-zero. Regardless of where exactly you land on this question, you're likely to get something out of today's exchange, including a few words about Leahy's own work on AI safety, which he feels optimistic about. To put this optimism into perspective, remember that we recently talked to Scott Aronson, the head of AI safety at OpenAI, the creators of ChatGPT, who openly admitted that he had no idea how to protect humans from the potential downsides of runaway artificial intelligence. Other notable highlights of this exchange are the brief descriptions of our own work on the threat of human extinction and a recent proposal we turned in to the EU in collaboration with a team of top researchers to use large language models and Carl Friston's work on active inference to simulate an experiment with different models of democracy. As is almost always the case when it comes to humans, Connor and I have different opinions. The key question for science, from our perspective, is not which model of the world is right, but rather how we're going to resolve our differences of opinion about which model of the world is right, and how we're going to do so without destroying ourselves. That, it seems to me and to us, is the key question. Still, I think Connor's work is key and fascinating and important, so I appreciate his time and yours as well. As always, you'll find a timestamp in the video description, and here, alas, is my exchange with Connor Leahy. Hello, everybody, and hello, Connor. Thanks so much for taking the time to talk.
Thanks so much for having me.
So you are the Chief Executive Officer of Conjecture, a for-profit AI alignment company based in London, I think. And so I'm the Executive Director of ASIM, nonprofit research center based in Barcelona. It's really interesting to see that in some sense we're both working on the same thing, which is long-term human survival. You maybe even short-term human survival, right? We take different angles in terms of identifying the root cause of the problem, and our proposed solutions are also a bit different. But our goal, I think, is pretty much the same. We both perceive an imminent threat to human existence, and we both want to reduce or eliminate that threat. So would you be nice enough to give listeners a layout of the landscape from your perspective in terms of AI alignment and the threat it poses to human existence?
Absolutely.
And if it's okay, let's assume for listeners that they're not experts. In fact, throughout our conversation today, if we keep things in general as possible, or at least zoom out to a kind of a general panorama, it might be easier for us to understand each other and for listeners to follow us.
Yep, absolutely. So I'm happy to talk about that. There's a lot of arguments and discussions around AI, AGI, and so on that are very technical. And one of the things I really feel is that a lot of this technicality is just noise. It's kind of missing that the core problems here are quite universal and quite easy to understand. And I think you'll find that we actually agree on a lot of things about the risks and where they're coming from. Because really, the way I think about things is that the thing I care about is long-term, civilization flourishing, humanity flourishing, us getting a good future, having a good future, a long future. And To do this, we have to, of course, leverage technology. Technology gives us great power, but power is neutral. It's neither good nor bad. Having more power of the environment allows you to do more good things, but it also increases the blast radius, so to speak, of both accidents and misuse of technology. What is the worst thing you can do with Stone Age technology? Then now you can club a couple guys over the head with a rock. What's the worst thing you can do with medieval technology? Well, maybe if you have chariots and longbows and so on, kill a couple people with that. Or maybe you could use tar to, burn down a city or something. Pretty bad. Oh, what's the worst thing you can do with gunpowder? What's the worst thing you can do with chemical weapons? What's the worst thing you can do with nuclear power? The the worst things, not just nuclear weapons, but also, what happens if there's a massive nuclear accident or whatever, and you irradiate the greater Tokyo metropolitan area. That's a level of destruction that was just impossible to even cause with previous technologies. So the way things are is that our technology increases in a sense exponentially. This is both good and bad. It's good because, we get all these great things, all these wonderful things we can do with our computers and our air-conditioned office buildings and whatnot. But it also has this downside of we have exponentially increasing danger from both accidents and whether military or otherwise misuse of technology. And if we don't have a way to deal with this, then eventually there will be technology that is so powerful that a single accident blows up everything. And there's no retries. After that, it's just over. So AGI is the obvious first technology that falls into that category, in my view, if only because AGI can very quickly invent any other technology. If you have AGI, this is AI systems that are as intelligent or more intelligent than humans. If you have such systems, well, logically, those systems can invent any new dangerous technology that humans might invent, and they can do it faster and more efficiently. So if we're worried about synthetic bioweapons or worried about, who knows, some kind of future device that we don't even know about yet, AGI, AI would be a quick way to achieve this. And if we don't control these AI systems, well, if it's smarter than us, more capable at politics, deception, business, science, and everything else, well, what do you think is going to happen? Just all things being equal, the future will belong to the machines, not to humans, not to us. They will be more competent. And we do not know how to control these things. So this is the question of alignment and control. It's this question of not just how you build a smart AI system, but how do you build a smart AI system that does what you want, or even stronger than this, that wants the same thing you want. And now this is a incredibly difficult problem, as I'm sure you can imagine. There's technical problems, but it's also even like just philosophical problems. What does it mean to want what we want? What does it even mean? What do we want? I'm not saying I have an answer to this question by any means, but unfortunately, as we see our computers, improve in exponential rate, our AI systems become more and more general purpose, more and more autonomous. I don't think we have much time to figure all of this out. So what I work on specifically, like Conjecture, is a subset of the alignment problem. Alignment would be the problem of, in my view, how do we make a system that is fully aligned with our values, that wants what humanity wants, that wants humanity to be great, that wants to do the right thing, etc. This is very hard, very, very hard. The simpler problem that we work on as a stepping stone is the problem of control. Is how do you make an AI system that does exactly what you tell it to do and nothing else? We approach this through an approach that we call cognitive emulation, or CoM, which is kind of about emulating human-like reasoning. We can talk about that a bit later. But I also moonlight with a nonprofit advocacy group called Control AI, which are working on the social and political problems of this AI and AGI transition. How do we, as a civilization, deal with this, that this technology is being developed? Is it a good idea that such powerful technology is being developed without any supervision, out of control by, private companies maximizing for shareholder returns? Seems like a very dangerous way to be developing this technology. If this is a dangerous way to develop technology, what is a better way to develop this technology, and how can we get there? These are very, very hard questions. These are very hard political questions. They're very hard social questions. I don't have answers to everything, but I have a few, a few pointers at least.
Excellent. Talk about some of the people who don't feel as concerned as Conjecture and the AI alignment community. What are they doing?
I think there's kind of like two main camps, or not camps, two main objections to this idea that AI will be a large risk. One is AI isn't a thing, or it won't happen soon. Either it's far away, it'll take a long time, or it's impossible for some reason. It's impossible to make AI smarter than human, for example, or it will take 1,000 years. The other position is it is possible to create AI, and we will probably do it soon, and it will be fine. Don't worry about it for various reasons. So there's a couple of different ways how people justify these various things. So for the first group of people, I think I would just kind of like point to the progress around us, and that even, you can talk to your computer now. You couldn't talk to your computer 3 years ago. Now you can. And this is crazy, and it keeps getting better. And there's a clear path forward. And we have, experts around the world now unambiguously saying, no, it's coming soon, and it's a big problem. So I think there it becomes an object level technical disagreement. I don't think it's a very interesting argument to be having. I think if we agree that there's even a 10%, 20%, 50% chance, whatever, of AGI emerging in the next 10 years or whatever, it would absolutely be worth us taking seriously. Like imagine we had a 10% chance an asteroid will hit Earth in 10 years and kill everybody. Obviously, everyone would be spending massive amounts of time working on this problem. So I don't think this is the interesting objection. It is a worthwhile objection, and it's worth discussing on an object level. But the other objection I find a bit more interesting, which is this objection that, well, maybe if we just build AI, it'll just be nice. Maybe it'll be good. It will just help us. We'll keep it under control. Maybe controlling it is easy, etc. And I think there's kind of a saying where like you have to be educated to believe something so stupid, where there is a core intuition that most people have when you first introduce them to the concept of AI and AGI, where you say, hey, some people, some technologists are building systems that they think will be smarter and more powerful than humanity, and they don't really know how to control them. How do you feel about this? And the default reaction is, what the hell? Like, of course this is going to go poorly. Like, have you literally never seen a movie before? Have you never thought about this for 10 minutes? Like, why? Of course this is going to go poorly. And now, the reason people form this intuition is often because of movies, which is not a good source of truth. But that doesn't mean the intuition is wrong. There's also very good ways where this intuition comes from, such as, look at colonizers from previous centuries. When a group of more technologically superior moved into a land of a less technologically sophisticated peoples, it often ended very, very poorly for the less technologically sophisticated peoples, to great horror often. Or even further, think about humans and animals. There's a reason that chimps don't run the world. Chimps may be stronger than us physically, but that doesn't matter. We have guns and society. We decide what's up. If we want to build a hydroelectric dam and there's an anthill in the valley, well, too bad for the ants. It's not because we hate the ants, not because we're malevolent, because we're evil, we want to, hurt the ants. They're just in the way. And I think this is what will happen with AI too. Some people think that what I'm trying to say is that AI will be evil. It'll be Terminator with glowing red eyes. I don't think that's what's going to happen at all. I think it will be mundane, and it just won't care. I think it will understand that humans don't want to be killed, but it won't care. It will be optimizing for something, who knows, more power, more profit, whatever. And in the process of doing so, humans will be in the way. They're annoying, they're confusing, and eventually you'll want to replace them with robots or solar cells or whatever. And to do that, why would you keep the humans alive? To put it in a more economic term, you can also think of it as the marginal contribution of humanity to the economy will shrink as more and more labor gets automated by machines. and including intellectual labor, until the marginal contribution of humanity falls to zero and then becomes negative, meaning that someone has to pay an economic cost to keep humanity alive. They need space, they need food, etc. And who will pay that cost? And by default, an AI system won't pay that cost. Why would it? Because we don't know how to make them want to pay this cost and not be outcompeted by other systems that do not want to pay this cost.
Very good. You have a very interesting way of talking about intelligence and goals. Can you elaborate on this?
For me, intelligence and goals are kind of two separate things. They're related. I like to think of it as, I kind of like to think about minds as kind of like split into four things. This is just my personal way of viewing it. I'm not saying this is the perfect way to view it or whatever. I just find a useful model. You can think of a mind as being composed of four parts. The first part is the world model. This is what the system knows about its world, about the environment. It's what it also knows about itself and what it knows about just its knowledge in general. The second thing is epistemology. This is how does it generate new knowledge? What systems, what logic, like how does it take in new information and derive updates to its world model from this? The third thing is its decision theory, which is given the scenario it is currently in and the things it wants to accomplish, how does it make decisions about what to do next? And the fourth thing is its values or its aesthetics. These are things that the system wants, and it doesn't want them for any particular reason. It's just the things it likes. So it's many goals, many things that humans do are not this well factored. Our brain is super messy. It doesn't have four compartments. All this is mixed up. For example, receiving money generally feels nice. If I give you a lot of money, it feels good. It feels like this is, and a lot of people put as their goal, I want to get money. This is a goal that in a sense of value that maybe lots of people have. But I think a lot of us will agree that really the reason we're getting money is not for the money. It's to spend it. It's we want to spend it so we can spend time with our family. We can go on a cool vacation. We can buy a toy that we want or good food or whatever. So for me, values or goals, or in the technical lingo, terminal goals, are things you spend money on because you want to spend money on them, not because they help you for other goals. It's a thing you ultimately want. So it might be, as I say, family, pleasure, whatever. Then separately from this is intelligence. And from intelligence for me is kind of like your general competence. So this is both how much is in your world model, like how many things do you know that are useful? How accurate is your world model? It's how good is your epistemology? How good are you learning new things? How good are you in integrating new information with your current world model in a sensible way? And it's how good is your decision theory? How good are you about making decisions? How good are you at winning at games? So ultimately, a very intelligent system can want anything. You could make a system that is very dumb and wants very high level things, that wants something complicated or something simple. The same way you can make something that is extremely smart. It's extremely competent, but it only wants to collect shiny rocks or whatever. Now, of course, evolution would never produce such a mind. It would never produce a super intelligence that wants rocks. But you could code it in a computer if you wanted to. Not saying you should, but it's possible. So similarly, if we build AI systems and we don't understand how to control them and how to control what goals they have, by default, they won't have a cleanly separated goal. It will be a mess. They'll have some thing somewhere where they kind of want to do something. And a lot of these goals will be contingent, and they will be about gaining resources, gaining money, gaining power. And the reason is because those things are useful. Most people like money, not because we all have a gene, in our genome that tells us to like money, but because we learn that, oh, wow, if I have a lot of money, then I can do many things. So therefore, it makes sense for me to get more money. I think a similar thing will happen with AI systems, where if we train them to do lots of different things, they'll notice, it's really helpful if I get money, so I should get more of that. Or it's really helpful if I can deceive humans and trick them, because then they'll do a bunch of stuff for me. So I should get better at that. So this is kind of how I think about it.
Yeah, very interesting. So you're kind of referring to a type of evolution then in that sense. Now, if a machine gains intelligence, then they will in some sense learn and evolve to toward their specific goals, or even if they don't have goals, right? Very interesting. Do you have a favorite approach to physics and artificial intelligence, or to quantum mechanics? What are your thoughts about connecting the two? Is there a relationship between the two?
I think they're kind of at different levels of abstraction. I think that intelligence is a very high level concept. It's not something that exists in the physics. It's something that exists at a much higher level. The same way that, we might say the United States of America is a useful concept for us to talk about, but it doesn't exist physically. It doesn't have a location. There's no atoms that compose the United States of America. It's an abstraction. The same way that like software is an abstraction. Like, where is the Google search engine? It's no specific location. It's data, it's information, distributed information. I think of intelligence kind of in a similar way. It's software that can run on many types of hardware. So there are interesting questions, such as, for example, what are efficient hardware designs? This is an interesting question. And there might be interesting questions around epistemology and quantum physics, for example. Like, how should you reason about the world, given that you're in a quantum physical world? How should this change your epistemology? But I think a lot of this stuff is contingent stuff. So I have takes on quantum and physics, as any Twitter schizo worth their salt has, of course. But I think, and I think there's a lot of things to learn, but I'm more interested on the AI side and the kind of a level above that, like the epistemology of like, how do you generate physical theories? I think is much more interesting to me personally than like, is this interpretation of quantum physics or this one? I'm much more interested in, how do you answer these questions? How would an intelligent mind approach this question, if that makes sense?
Yeah, that makes a lot of sense. Do you think that, I always argue the following, that amongst the different interpretations in science as a whole, and in quantum physics in particular, that I always say
Yeah.
that theory or that interpretation that most leads, or most effectively leads to long-term human survival, should by default to be the preferable interpretation. So if a person's interpretation has nothing to say about that, about human survival, then it's not as meaningful as one that can be connected, of course, in a meaningful and scientific way, following the scientific rules. So I ask about that because we take in terms of control, your concerns about controlling AI, and about the physics of these concerns that both you and I share. Our approach is that the goals that are necessarily at the fundamental physical level, built into all of matter, including AI, one of them is the principle of least action. And the principle of least action is, of course, one of the most fundamental principles in all of physics. It just permeates almost every aspect of physics. Not accidentally, I would say, Juan Maldacena, who is arguably one of the most important physicists alive, according to another incredibly important physicist at Stanford, Leonard Susskind, Maldacena refers to the principle of least action as the principle of maximal life. So he says, and he demonstrates, and he argues that particles at the subatomic level, down to the quark level, whatever, move in such a way as to maximize their experience of proper time, or their experience of existence. So this is at the from the Big Bang on, it's been a fundamental driving principle in all of evolution. So it stands to reason that if this is in fact the way nature works, then intelligence, like you said, it's at a higher level, but intelligence is always driving matter in such a way as to exist for a longer period of time. That would explain, at least to some extent, on a very metaphorical, perhaps directly literal sense, the universal desire of all living things to remain alive. Why humans don't want to die. So there seems to be a fundamental physical reason for this. So the concern about creating an intelligence that we cannot control almost necessarily implies, like you said, the death of humanity, precisely because physical material moves and evolves in such a way as to maximize its own experience of time. So I think this is a really, in my opinion, it's a compelling argument in terms of why not to build something that you cannot control, right? So I think this is, I mean, this lays it down in terms of the physics. Now we get to the control. How do we actually control? And that's of course one of the primary things you are working on. And if we really dig deeply into this question of control, we necessarily bump up against the idea that all humans have different models of reality, of different opinions about how things work. And this seems to be on an equal footing, or perhaps even more important footing than the AI question itself. Because if we can't agree about what to do, then that doesn't get us any closer to solving the problem. So my next question to you is, how do you think about, you mentioned earlier a certain group working on the social and political aspects. How do you think about those questions about political theory, social theory, and the fact that we can't agree on virtually anything? How in the world are we going to agree on something like AI or AGI?
So this is a great question. And the glib answer is that like this is why I am pessimistic. No, but this is not true. This is just one of the reasons. It's actually much worse than that. The truth is that this is a very hard problem. And anyone who tries to sell you something else is selling you snake oil. This is anyone who says, oh, it'll be fine, just don't worry about it. Or like, oh, we just do X and then it'll be fine. Is just not truly engaging with how hard this problem is. The problem we're solving for here is not a software problem. It's not like, oh, how do we write this algorithm? How do we solve this math proof? The problem that we're solving for is like, how do we design and implement a global, stable civilization that fulfills our contradictory values between, 7 billion humans? This is an astronomically difficult problem. This is an extremely difficult problem. That doesn't mean it's impossible, but it means it's very difficult. So with that being said, it's very tempting and fashionable nowadays to talk about how we don't agree on anything. And it does feel that way, especially if you spend any time on Twitter. But the truth is that we actually agree on a lot of things. There's actually a shocking amount of things that people across the world actually do agree on. Such as, and there's exceptions, of course, but like for the most part, especially here in the West, is that like you don't do violence. This is a good norm. The fact that we don't, have violence both politically or otherwise, as we did 100, 200, 1,000 years ago, is really great. We can agree on a lot of things there. We can agree on the value of various major currencies. We can agree on various laws and social norms and communication norms and so on. It's possible for you to meet a random stranger at a restaurant who you've never met before, and you don't have to feel scared because you know you'll be safe. This is not typical for the history of mankind. And it took a lot of work to get to this point. It took a lot of social work. It took a lot of political work to build systems that allow these kind of transactions to happen safely and efficiently. And I think the kind of things we need to do are on this axis. In a sense, the thing is that it is in no one's interest for humanity to be destroyed by AGI, except for a couple misanthropic, crazy people. But for the most part, it is not in people's interest to have, uncontrolled AGI or bioweapons or whatever. It's not that people don't want this. If people didn't want humanity to survive, we would be in a bad spot. But I've checked, and most people love their kids. They love their family. They love, they might have some disagreements with a lot of people, but all things being equal, like an average person, if you give them the chance to press a button that makes someone's day better or not press the button, they'll press it, all things being equal. This is really nice. It's nice that humanity is like this. Many animals are not like this. And so if this is the case, why is there a problem? So there's one of I think my literally favorite snippet of fiction ever written. I'm gonna butcher it, but it's from the Principia Discordia, where the main character is talking to the goddess, and he says, "Oh, goddess, things are so terrible. There's war and famine. Brother fights brother. There's chaos. It's so awful. What do we do?" And the goddess says, "Well, if that's what you want, what's the problem?" And he says, "But no one wants this." And the goddess says, "Oh, well then stop." And so I wish I could write something this witty, because it's so perfect, because it's true. Like, there's so much going on that no one wants. Like, no one wants children to be dying of famine somewhere. No one wants this. No one wants people to be, victims of violent crime. No one wants, this stuff. All this is bad, and yet it keeps happening, and people keep doing it. Why? And there's no simple answer. There is some, cute answers, some cutesy answers you can give, such as quoting Moloch, which is a name from a famous essay on this topic, which just blames everything on this entity called Moloch. And this entity called Moloch is the entity of Nash equilibria, which are not Pareto optimal. And what this means is that if you're playing a coordination game, if there's a way where a group wants to work together, you can get into situations where it would be better for everyone to do something else, but if any individual tries it, they lose. They can't do it. The whole group has to do it together. So you want to get the whole group to do this thing, but any individual has no incentive to do it. This is an extremely toxic situation. This is an extremely bad situation. And this is extremely common in these political problems. Often when you have sticky political problems, the reason they're sticky is usually not because there is not a possible better solution, but to get to that possible better solution, someone's going to lose their job. Or, the bureaucracy enforcing it would have to cut their budget, and they don't want that. So the ones who could cause the problem would lose from benefiting from implementing it, or it would be annoying to implement it, so they don't. So how do we deal with these kind of problems? There are many, many ways how to address these kind of problems, and most of them are hard. But overall, what we need is a civilization that is more coherent and capable of coordinating around these movements. So one of the most important mechanisms around this is common knowledge. So common knowledge is different from knowledge. Knowledge is knowing a fact. Like, I tell you something, now you know this fact. You have knowledge. But this doesn't mean that common knowledge exists. Common knowledge is when you know that I know, that we know, that our group knows, that they know, that we know, that all of us know, etc. And this is extremely important, because this is the unit of coordination. Let's say there's 3 candidates for presidency, A, B, and C. A is the preferred candidate. He is the incumbent. He's probably going to win, but everybody hates him. He just sucks. No one actually likes him. There's B, who is almost just as bad, but maybe slightly worse. So he gets a little bit less votes, but he's also terrible. So you have 60-40. And let's say there's a third candidate, and this third candidate is the best. He's actually amazing. He's extremely good. He's just unpopular. People haven't heard of him before. So now imagine I go to, the 10 voters or whatever, and I tell them, each of them individually, and I convince them that C is this amazing candidate. He's the best candidate, and they should all go vote for C because he's the best one. And they might all be convinced of this. Let's say I convince every single one. What happens on polling day? Everyone votes for A, because B is even worse. We don't want B. And, well, if I vote for C, that's just wasting my vote and helping B, because everyone else is going to vote for A. So I have to vote for A as well. So what is missing here is that all those 10 people have to also tell each other that they're going to vote for C. They're oh, you're going to vote for C as well? So am I. Oh, wow, you were too? We're all voting for C? Well, fuck yeah. Now we can vote C in. If you don't do this, if you skip this step, C will never win, even if he's the best candidate. Doesn't matter, because everyone will coordinate on A. So a big issue, so one of the most important things to do around the AI problem and the danger from AI is literally just making people aware of it. And not just making people aware of it, but aware of it in a common sense, that also everyone now knows about it. Everyone knows that you know about it. And it's not something you can ignore. It's no longer weird to bring up. It's something that your government should have an opinion on. It's something that your elected official should somewhere have a statement, and if he doesn't, you should ask him. And it's normal for you to ask. Your friends won't look at you weird for asking about this question. And once we move these kind of things into the cultural common knowledge, it's a thing that our civilization can reason about. So that's step one. Well, it's step two, I guess. Step 0, humanity not wanting to die. Step 1, bring the object into memory so that you can reason about it. Step 2 is that you need to make civilization coherent and competent enough to actually act. There needs to be an actual plan, and there needs to be a way to enact this plan. And step 3, enact the plan. Currently, we're still on step 1. How do we even get civilization to think about these problems? And then we have to, and then as we're also starting to tackle this problem of, okay, what can civilization do? How would it be enacted? This is very hard because a lot of our institutions are not very good. They're very calcified, they're very slow, they're very efficient, and this limits what kind of plans you can execute. Even if society decides, okay, we're going to do something, the complexity of the plan is limited by the competency of the institutions that are executing this plan. So this is a very hard problem. It can be both improved by improving the quality of institutions and by making cleverer plans that are better suited for the system you're working with. You need to do all of this. If you skip any of these steps, you lose. So this is very hard, and we work on all of these problems.
I agree. It's really, really hard to imagine that kind of scenario because you're running up against, of course, several academic disciplines that are already very well developed. Among them, social choice theory, which deals with how collective decisions are made and how votes are aggregated, and there's just inherently difficult problems and challenges to imagine that we can somehow get everybody to agree or mostly agree on even something as basic as long-term human survival. Look at the climate change issue. Even scientists can't agree on this, whether or not climate change is real. Unanimously, rather. I think most people agree that there is a problem, but there's still enough controversy to generate quite a bit of people who feel the opposite. So it's very, very challenging. Are you optimistic that we will be able to do something about this before the AGI deadline?
Something? Yes. Enough to save us? No. I don't expect we'll make it. I am quite confident that we're not going to make it out of this century alive. Maybe not this decade. It seems very unlikely at this point to happen. It is not impossible. There is no physical law that prevents us from just doing the right thing. There's nothing that prevents humanity from coordinating at this speed. There's nothing that prevents us from solving the alignment problem. There's nothing that prevents us from, delaying AGI creation with laws or institutions or social norms or whatever. There is no physical reason we can't make it. But there sure is a hell of a lot of social pressure going against it. There's a lot of economic incentives against it. There's a lot of cultural incentives against it, a lot of political malaise that are pushing against it. And if I thought I had like 30 years, 50 years, 100 years time, I would be feeling a lot better about this because that's a lot of time to make social change. But making social change on a, 10, 5, 1 year frame, hard, but not impossible. And I'm going to try. I am trying. And so are other people. And I think it's important that we give it the best shot we can. And it is possible, but it will be very hard. It also depends on how hard the technical problems are. So there's a massive social and political problem, but there's also a technical problem. It's neither one nor the other. It's both. It's that we don't know how hard aligning AI is. It could turn out to be anywhere from surprisingly easy to almost impossible or completely impossible. And depending on how hard it is, will change what kind of plans we need. If it's literally impossible, which I don't expect, but it's possible, maybe, then we need to do some very drastic things if we want to survive into the long-term future. If it's super easy and not that big of a problem, okay, well, then we should verify that. And if we verify that, then we can go easy. Awesome. Like, that would be the best world. But we don't know. And most of the evidence that we have points towards it being pretty damn hard. So it's given that it's hard, we don't have much time. There's both a strong technical problem, which very few people are working on. It's shocking to me how few people seem to want to work on this problem, or at least have the incentives to work on this problem, including academics. Like, it seems to me as if I was an academic, this would be the #1 problem I want to work on. But the number of academics working on the problem of super intelligent alignment is minuscule. Like, last I checked, it was less than 200 in the whole world, and which is crazy for a problem that's this hard. I don't think like the fact that it's just like some guy in London, some hacker, who put together a small company and is like among the largest labs in the world working on this problem is not a good place to be. Now, I love my engineers, my scientists. I think they're some of the most brilliant people in the world. And they give me hope every day that maybe we can make progress on this problem. But we're in a bad spot if this is if this is what we have to rely on. It's similar where how I often talk to journalists and they ask me questions like, is Sam Altman nice? Like, does he care? Is Demis a good guy or a bad guy? And my answer to this question is, it shouldn't matter. We shouldn't have a system where whether the future of AI goes well depends on whether some CEO is a nice guy or not. This is not a stable system. This is not a good system that we're in. So I'm very pessimistic in the sense of I don't think we have a high chance of success, but it's not impossible. I do see ways. I've ironically had a experience over the last couple of years where timelines have gotten worse. Things have progressed faster than I expected, and I already expected very fast progression. Many political and financial things have gone much worse than I was expecting. But at the same time, I'm seeing more solutions. I'm seeing more plans that could actually work. So it's been a kind of a tug in, both directions for me as like up or down in probability of success. But I think this is very, very, very hard. And if nothing changes, if we just continue at this pace, the way things are today, here in 2024, then we're definitely not going to make it.
Well, you raise a really good point there that I often tell people. I'm lucky enough to interact with some really bright people around the world. And I often repeat, I don't understand why more people aren't concerned and working on this. So it's kind of insane, the fact that, if our families, for example, or our children were in a position of danger, they're on the edge of a cliff or something, they're real danger, it's like completely ignoring it and just letting them play and frolic at the edge of a cliff. It's difficult to understand. We've been lucky enough to get some really bright people on board for our research program. And I suspect that there's a couple of scenarios that could play out here. Number one, our concerns about large-scale catastrophe or even extinction might turn out to be false. It might turn out to be real. It might turn out to be so real that humanity ends. It seems to me that a more likely probabilistic scenario is that we're too late to really change anything. What you're trying to work on, what I'm trying to work on, what several people around us are trying to work on is daunting. It's incredibly daunting. How can we possibly get people to understand and to change their behavior? I see it really difficult. So I think it's too late to really do anything. I think we're going to learn a very difficult lesson about. I'm crossing my fingers and hoping that not everybody dies, so that there's some people left over that can look back historically and say, this is where we come from, this is what happened to our previous systems. Now we have to create something different. Unfortunately, in that scenario, even in that scenario, unless something different is created, that next generation is going to confront sooner or later the same problem, right? So that's I think the essence of what we're dealing with here. The problem of how do we stop ourselves from destroying ourselves? And going back to the principle of least action, or what Maldacena calls the principle of maximal life, I suspect, and we've been working on this concretely with, like I said, some top researchers, some of them you know, that one promising potential comes through a combination of physics and social choice theory. I suspect you're familiar with Glenn Weyl's proposal for quadratic voting. So Glenn Weil is one of our research partners among this research team that we're talking about. And so what we're trying to do is connect his proposal for quadratic voting to down to the fundamental physical level, and then proposing a new way to make collective decisions. I don't think it's going to work for this generation, but I think it may be interesting for the next generation, or after the lesson that humanity learns. And it's the idea is, how do we control AI? Again, this is theorizing, right? If all material has a propensity to seek out its own existence for as long as possible, the answer is to build into those physical systems, into our political systems, the opposite. Some kind of altruistic algorithm, or some kind of self-sacrificial algorithm that controls the impulse to only I survive. Rather, if we get our political systems, our social systems driven by the idea that I'm not the thing that matters, but rather, or I'm not the only thing that matters, but rather we matter. If that's the fundamental principle, without going all the way, obviously, to something like communism or anything like that, if that's a driving principle and we can get it into the physics and into the artificial intelligence, that seems to me like a promising avenue to explore. Does that make sense to you? Well, I'll leave it there. Does that make sense to you?
I think there's a lot of things that are worth exploring, for sure. I think there's a lot of inspiration to be had in mechanism design, familiar with Weyl's work and, Levin's work on tumors and how do systems coordinate at this kind of level and so on. It is a general question of coordination. In a sense, you could say that alignment is very much a hierarchical problem. It goes down from how do cells prevent cancer, how do multicellular organisms coordinate with each other, all the way up to, how to friends coordinate, how do companies coordinate, how do governments coordinate, how do governments coordinate between each other, and so on. So it's very much a general abstraction that we see appearing over and over at different scales. Arguably breaks down at the small physics level, unless you want to recast, elementary particles as coordinating mechanisms, which you can use energy as a currency and clear the market and so on. It's possible to cast it this way, and maybe it's a productive way to cast it that way. I'm ambivalent on whether this is a productive direction. I guess the way my usual quip, I guess I would say on this, is that to do truly incredible things, things of this magnitude, of just incredible proportions, you need to do exactly two things. The first is you do things that compound. The second thing is don't die. If you do those two things, you can accomplish things that seem impossible. So I think the kind of work you talk about is a thing that can compound. Improving mechanism design at scale is something that can compound. If you can do this over a large scale of people that, potentially growing population or growing in terms of epistemology, wealth, etc., this is a thing that compound. Getting you 0.1% more growth per year is very powerful if you can do it over 100 years or whatever. Then the bottleneck becomes don't die. So if I had 100 years, 1,000 years, if I thought there would be a next chance, if I thought some people would survive and they'll get a second shot, I probably wouldn't be working on what I'm working right now. Maybe I would. But I think there are ways of how you can solve alignment entirely for superintelligence on the first shot. But it's unfathomably hard. And it starts with, dealing with incredibly fundamental questions of epistemology and foundations of mathematics and whatnot. And this is not the kind of thing you do if you think you have a limited amount of time and a limited amount of coordination budget around what to coordinate your civilization. So I feel this this feels like somewhere in between, where I think the bottleneck right now on us surviving is not really galaxy brain brilliant scientific stuff. It's mostly boring labor. It's talking to politicians. It's producing good media, talking to the general public, digesting things into words the general public can understand, message testing, and just hacking away at the control problem in a more prosaic way. Like, how can we build AI systems that are not super intelligent, but are still useful? So we still get economic growth because this is easier to coordinate on. This is part of what we do at Conjecture, is we try to build AI systems which are bounded in the sense that they're useful, they're powerful, and they're reliable. And you can use them reliably, and you can ensure that they don't lead to existential risk or such problems. This is not because this is the best possible thing we could be doing. It's because it's a good thing to coordinate around. It's much easier to get a government or a company or someone to sign up if you say, hey, this prevents this, tail risk and also makes you a lot of money. This is a very easy, useful way to get people to work with you, is if you just promise them to also make a lot of money. And if this is, of course, true. So a lot of these academic things, I like that someone is working on them. I like that there are some people in the world out there who are thinking about, physics-inspired mechanism design, that are thinking about formally provable retrocausal alignment schemes, shout out to my friend Carado on that one, and other things.
Say more about your friend. The
Carado. She's a researcher working at a work called Orthogonal, and they have one of the most galaxy brain fucking insane idea of how to align AI, where they build an AI that destroys the universe, but then resimulates it and goes backwards in time to think about what the researcher actually wanted and then locates that formally provable. It's insane. Obviously, it won't work, obviously, but it's great that someone's thinking about this, right? I'm glad someone is thinking about this. I think honestly, with all my love to Carado and other people in this category, I think too many people are thinking about this stuff right now. I think these people would do much better if they just literally start doing politics. And just boots on the ground. I'm not even talking about galaxy brain planning, just boots on the ground politics. I think right now is higher leverage, but this is a contingent fact. At some point, we need to think about the complicated big stuff as well. It's one of those great things where I'm a big fan of quadratic voting, prediction markets, all those good classics, that your GMU, associated people love and whatnot. Love them. But prediction markets are just illegal in the US. Sure, you could come up with a better proper scoring rule that incentivizes the correct, crypto decentralized actor thing. Okay, but they're still illegal in the US, and they're illegal for a really stupid reason. The reason they're if you don't know, you should look it up. The reason they're illegal in the US is just stupid. It's not even someone passed a law to outlaw them. It's just one branch of the government decided it fell under the jurisdiction, they shouldn't do it, and no one ever basically challenged it. It's stupid. And the bottleneck to doing that is not you have to come up with an even cleverer market design. It's you need to actually lobby the government, and you need to actually talk to people and explain things to them and make things legible. This is the thing that some prediction markets recently have done a much better job on. Like recently, there's been, prediction markets suing the government, going through the process, and so on. And this is all horrible and terrible and annoying, and it feels like a waste of your time. And it is, but it has to be done. So my claim is that I think we are currently not bottlenecked by the smart stuff. I think we are bottlenecked by the stupid stuff.
Okay, so point taken. I think your approach is interesting and important, and I agree that many different approaches should be taken. And the boots on the ground, lobbying politicians and whatnot seems like the most directly doable, rational approach. But what do you do about the fact that people don't agree, even on approaches to AI? If you have line up, let's imagine, I don't know, a few people who are doing AI research, and you ask them, should we continue with this or should we stop? And 6 of them vote to continue, and 4 of them vote to stop. If it's a democracy, then you go ahead with AI and presumably with AGI. Isn't there a problem with, even if you go to the politicians, if you just submit this to decision theory or social choice theory, isn't there still a problem?
So this is what I was talking about earlier about step 0. You have to want to not die. If people want to die, yeah, we're just screwed. And I'll go retire to Hawaii and, with my family and have a good time. I probably won't. I'll probably still fight. But, if we did a truly representative global poll vote on literally the whole world about whether unelected, technocrats in Silicon Valley should be allowed to build technology they themselves think and have said could literally kill everybody. And if more than 50% vote yes, okay, you know what? This is already a much better world than we're in right now. Because right now, no one's even being asked. There is no common knowledge. There is no discussion. It's just happening anyways. So if we get into this world and that's the result, I'm already happy. This is already so much better than where we're at right now. This doesn't know if this happened, of course, I would immediately start working on, hopefully changing people's minds and so on. But still, this would be a massively better world than where we're at right now. And also, I just don't think it would be over 50%. I think, and there are polls, we've done YouGov polls in like the UK and the US around this. And no, the overwhelming majority, bipartisan, say no, this should not be just allowed without supervision. And, this shouldn't just be, we shouldn't race forward at all. This is bad, actually. And so if we had a democratic oversight here, a coherent democratic process with teeth, I think we would be in a much better spot than we are right now. This doesn't solve all the problems. But as I say, we need to do 2 things. Things that compound and not die. So this would give us a lot of not die points. And if we had more not die points, we can spend these on clever things. So you ask this question of like, okay, but people don't agree on values and things and whatever. And this is a hard problem. And I'm like, yeah, okay, seems like we need a lot of time to figure that out. I don't think we're going to figure this out in the next 6 months. So if we can't figure it out in the next 6 months, we have to make sure we don't die in those 6 months. Because if we do, then we're never going to figure it out. So is it possible to develop a better mechanisms or a better aggregation or enlightenment at scale or whatever the hell to make people agree more on things or like find better compromises? Probably. And I expect those things will take longer than, 6 months. And so we have to make sure that we don't die in the next, 6 months, 12 months, 3 years, whatever. We need more time. I think we can make progress on this. If I had 30 years, I'd probably be working more on mechanism design or global preference aggregation and stuff. I just don't think we have that long, basically. So we have to first work on the not die part. And if we get the not die part, then we can, start thinking about, not just start, but then we can like put more of our efforts. I think currently the number of people who are working on the boots on the ground, just don't make sure we don't die over the next couple of years, is vanishingly low. And the amount of lobbying dollars that goes into lobbying against the creation of superintelligence by unaccountable, unelected, technocrats is a pittance. It's almost nothing compared to these large behemoths. You know how much Microsoft pays for lobbying? Like, how do you think like groups like, me are supposed to compete here? I mean, we can and we do. And the main thing we compete on is that we're right and people don't want them to do this. It's very expensive to convince people of things they don't want. It's quite cheap to convince people of things that they do want. And so we have a chance there, but like it is hard and it's not easy and we would benefit. I wish there was 100 organizations of control AI. I wish there were 100 conjectures of small, medium, even large players pushing against this kind of stuff, even just by making noise, even if it's just by, talking about it a bunch on social media, if it's by writing letters to your congressman, like whatever. Like there's just not that much. And I'm not saying there's a massive amount in mechanism design either. Also underfunded, terribly underfunded. There's a lot of work to be done there. But in my personal view, at this point in time, I think we would benefit more on the long term if we could all coordinate to temporarily just solve the concrete problem to buy us more time, and then we can redistribute on longer timelines, in my opinion.
Yeah, very good. The one contradiction I perceive, or the tension maybe is a better word, is the idea that you're very clear about what you're trying to achieve, yet at the same time you say that it's not possible, that you're pessimistic about it. So help me understand that those different ideas.
Not possible and almost not possible are very different. I forget how the quote from Princess Bride goes, but he's not dead, he's almost dead, which is very different. Humanity isn't dead, it's almost dead. That's very different. The way I kind of see things personally, so I'm just speaking for myself here, is that even if I thought humanity was dead, even if I thought there was no chance, I still would try. Like I don't know how to save the world, but damn it, I'm gonna try. It's kind of just my nature. Like I've always just kind of thought this way. The way I kind of think about this is, and this is a question I get a lot, is like, Connor, aren't you depressed? Like, isn't this scary? Aren't you sad? Like you think we're all gonna die? Doesn't this make you upset? Does it make you sad? The truth is, not anymore. Like I've kind of grieved. I'm kind of over it. And the way I see things now is that, look, we're facing unbelievable hardships, unbelievably hard, massive problems. There's huge monsters, behemoths, villains that are standing in our way, often to their own detriment. There's incredibly difficult technical, social, political problems with overwhelming odds against you. And that's true. But, I get to work on the most exciting problems in the world. I get to try to make the world a better place with all my might. I get to work with some of the most brilliant, wonderful people I could ever ask for. I get to spend time with my family, eat good food, even if we don't make it, even if it goes poorly, even if we, don't make it out, then it's a life worth living, and I have no regrets. That's how I live my life. I'm happy I tried. If we don't make it and we die, I want to be able to look God in the eye and say, I tried.
Well, I applaud your effort. Definitely, I applaud it. In fact, I wish I would have come across your work a few months earlier, prior to writing this grant application. Have you worked on any kind of simulation using LLMs? Just out of curiosity, because the application that we submitted involves using LLMs to simulate different scenarios precisely in order to test various voting algorithms and different social situations to convince people that something needs to be done. Have Have you experimented with any kind of sort of simulations? And if so, please tell us about it.
A long time ago, I experimented with this. This is back in like the GPT-2 days, or GPT-3 days. I experimented with these ideas. These were some of the first ideas that came to my mind as well. I was wondering how much you could use this to, for example, create artificial like opinion or cultural polls, or to stress test or role play through negotiation scenarios, or like message test for cheap. Um, back then it didn't work very well. Models were not good enough. I think modern models are a lot better at this. I think they will have predictable biases and failure modes here. Obviously, it does not, replace human interaction, but it's obviously a powerful tool. And compared to how cheap they are, compared to the data you can get, they're obviously extremely useful. I think there's a lot of low-hanging fruit here where you can do a lot of like digital social science, as long as you remember it's not actually social science, but it is proxy. It's a proxy metric. It's a noisy proxy, but it is a proxy. I think there's a lot of massive amount of alpha that can be gained there, where just if you iterate super, super quickly, like I think the bottleneck there is good software engineering and like good iteration, just like doing lots of experiments very quickly. Because that's the thing you like can't do with humans, right? Like you run a poll, you can have like 10 questions of like, 2,000 people, and it costs you like a lot of money to do this.
A lot. Yeah, exactly.
Exactly. So if you could do the same thing, but your questions are like more noisy or less good, but you can do it on 2 million samples, like that should change how you think about doing science here, and then like what you verify. Like the right way I think to design this kind of thing is like you do massive amounts of digital stuff to hone on the right questions to be asking, and then you point to verify these things in the real world or something like this. I'm not a social scientist, I'm not a statistician, so I can't say I know the exact right way to design these kind of things. But I do think there's a lot of possibilities there that I'm sure some people since then have tried, and I have not read your papers. Sorry, there's too many papers to read. So I'm sure there's other people who have tried this kind of stuff in a more sophisticated way than I have. I, of course, as I say, personally do not feel bottlenecked by this kind of work. But if I, had access to extremely good tools around this and was low cost to like message test at scale with LLMs, yeah, I think that could be helpful.
Yeah, fantastic. That's good to know. That's very promising. Yeah, we as a group obviously feel very, very optimistic about the possibilities here. In fact, we're if you're interested, we'd love to include you as in the efforts. We've just started another group of sorts that includes Wolfram Research, basically aiming toward the same thing of using LLMs to simulate agent-based models, etc., using some really interesting stuff from Michael Levin's work on, hierarchical levels of intelligence. What he calls it the multi-scale competency architecture. And then we have, I mentioned earlier, a physics approach. We have, I don't get tired of promoting this approach to physics, which is the two-state vector formalism, which posits two boundary conditions to understand the nature of some of the mysteries that we experience on an experimental level in physics. And this goal-oriented approach from the quantum level through Levin's work, through Friston's work, all the way up to democracy. We never know. If we have 3 years, maybe our paths have some promising potential, because if we can simulate things and convince governments through actual simulations and through very rigorous science and rigorous physical and mathematical arguments, I think it could add to the boots on the ground. I think the boots on the ground is obviously really important as well. So, like I said, I wish I would have come across your work a little bit sooner, precisely because of that, the LLM approach to agent-based modeling.
Yeah,
Fantastic.
I think it's definitely interesting, and I don't want to dismiss like that, very good simulation, technical arguments, and so on can have value, but at least, also to share with the audience, because I think this is interesting potentially for a lot of the audience. I've talked to many, many politicians now. Like I'm a tech guy at heart, right? Like everything you just say, I'm like, ooh, that sounds so fun. Like I want to work on that. That sounds so cool. It's like exciting. It's fun. You have Levin, you have Friston, you have Wolfram, you got the whole crew. Like, you got some of the funnest people in science, together there.
Absolutely,
So
absolutely,
yeah.
yeah, absolutely.
Yeah. So I totally get it, right? Totally. I love this stuff. I think this stuff is super cool. And I was almost disappointed, but it's good now that I'm calibrated on this. It's just like, man, it is good logical argumentation and scientific data, just not the bottleneck on convincing people. Like this is just truly, truly not the bottleneck. I wish it was the bottleneck. I wish we were at a point where everyone was so rational, our institutions were so efficient, our group epistemology was so good that the thing that was holding back, say, climate change discourse is more, ICE core readings. If that was the thing holding us back, I would be like, wow, we're in a good spot. But the truth is, the things holding us back are having nice dinners with politicians and making them feel safe and making them feel like you're trying to help them and explaining things to them in their language. It's so often that I've spoken to politicians, and these are high ranking politicians, mind you. These are like top UK people, and these are not stupid people. And they're just like, and I, spend an hour or two with them, and they're just like, wow, no one has explained this to me before. And I'm like, damn, like if this hasn't been explained to this guy who's like a very high ranking member of government in a very major country, then no one knows this. Like no one is being told this. And these are not high level, these are not complicated explanations, right? These are very simple, just here's a basic fact about AI, here's how AI works. Like most people don't know that like AI isn't coded. Like most people don't know that AI is trained and that we don't know how the internals is. Almost everyone I talk to does not know this. This is a very, very basic fact. And just telling this to literally every politician is already extremely high value. And the bottleneck to getting to these politicians and other leaders of various kinds is not that our argument isn't good enough. They'll believe you. You can give the argument, like, huh, yeah, that makes sense. And they might double check it with their science advisor or whatever, but the science advisor will agree with you. They'll be, yeah, we don't know how they're written. It's that here in the UK, we have what, like 300 to 500, major politicians that you need to talk to. This is before we talk about like cabinets, ministers, deep state stuff. US government is much bigger than that still. There's 190 countries in the world. You multiply all these numbers together and you get a lot of people you need to talk to. And even if every conversation is not difficult and could be done by, you, me, anyone really, each of them takes an hour or 2 hours, and it takes you takes you a while to get an introduction and to convince them that it's worth talking to you and whatever. That adds up to just a lot of man hours. That's a lot of hours you have to spend. And it's not glamorous, cool work. It's just things that need to be done. I would like us to get to the point where we've done all the stupid things, where we've like, I'm kind of repeating myself at this point. I'm sorry. It's like I want to get to the point where we've done all the stupid things. We've talked to literally everyone. We've made all the dumb arguments. We've got all of this, done. And now we're bottlenecked because our science isn't good enough, or we don't have a convincing enough, thing. We get to that point, I'm like, awesome. That's a really good world to be in. And so there's a little bit of this where, like, for convincing technical people, this kind of stuff is very valuable. So like the stuff you're talking about for like professors, intellectuals, for this kind of stuff, for that it is very useful. But I found it shockingly unhelpful anywhere else.
No, that makes sense. That makes sense. In fact, our strategy is precisely trying to address this difficulty. And we think that quadratic voting, amongst other approaches, could be a promising way forward. For example, if you're assuming, for example, that the voting mechanism is democracy, one person, one vote. But if you change that assumption, then voting theory becomes a lot more interesting, because if we allow the Connor Leahys of the world to have more say in whether or not we proceed with artificial general intelligence, then the better decisions are made. So that's precisely what we we're
Yeah.
trying to get, but I agree with your point. I'm sorry, go ahead.
Yeah, I was gonna say I love this. Like I think quadratic voting is a great idea, as is like rank preference voting and like all these superior systems. I think all these things are really good ideas. They really, really do. And I think if we can get this implemented, it'll be fantastic. I expect the thing that is preventing these things from being implemented is just mostly social. It's gaining reputation,
Absolutely. No,
talking to
absolutely,
people.
absolutely.
So someone has to do that. And I would advocate to our lovely audience of talented, smart, handsome individuals to potentially considering that this work is extremely important and could use your talents.
I agree. I agree. Absolutely. I double that motion. Let's spend the last couple of minutes talking about Conjecture. What are you doing at Conjecture? What's taking your time? Tell us about your team. Tell us anything that you think would be valuable for the audience to know and for myself to know.
Yeah, so at Conjecture, we kind of grew out of my previous project, which was I was the founder of Eleuther AI, which is a large open source ML research community. I don't do open source anymore because, unfortunately, I feel timelines were much shorter than I expected, and open sourcing AI models can become very dangerous very quickly. So I don't really do that anymore. I so basically, but I met a lot of great people, some of the best engineers, you could imagine, and we all crowded into a, oxygen deprived little WeWork in London about 2 years ago now. And so since then, we've been working on the problem of how do you make AI systems controllable? This is a technical problem. And so we have been thrashing our heads at this problem for 2 years straight now. We've tried many different things. We've gone from many different directions. We've taken and dismissed many things. We've built state-of-the-art large language models in-house, like way before like Llama existed. We already had like really like Llama level models internally and so on. We've done a lot of interpretability research. We've done stuff like simulators. We've tried many things. And after a lot of things of iterating and finding things, we now have something that we're really actually optimistic about for the first time. And it's kind of a weird word. Like I feel like I still haven't emotionally even come to terms with like, oh wait, this might actually work.
Oh,
And
good.
yeah, for the first time in my
Wow.
life, I'm like I still myself am like scared to be too optimistic about it, but like I'm like it's actually looking like it's gonna work. And so the approach is what we call cognitive emulation, or COEM. And the idea is that it's a vision for how to build AI systems, still using LLMs, but instead of the usual LLM way of just like training in a bunch of shit and then, running it on whatever, we think far more principled about the problem. We think far more principled about cognition. And we break down cognition into more elementary blocks, into more elementary pieces and steps that a human would use when solving a given problem. It's like when you approach a problem, what are the steps that you as a human actually use? And what we do is we build models and we train models. We've developed some really cool algorithms in-house. I unfortunately can't talk about. We're quite, a bit strict about how we accomplish some of the things that we accomplish. But we developed some methods internally to be able to train on very small amounts of data for very high efficiency and very high reliability. So the idea here is you build systems that can do fundamental pieces with perfect accuracy and perfect reliability. And then from this, you can then bootstrap and compose into larger and larger and more complex things while still understanding every step of the way. So the idea is that you build systems. I say systems, not models, because, of course, there are LLMs at the heart, but it's more than that. It's also about having, you modify the sampling algorithms, you modify the, there's scaffolding, there's memory, there's a bunch of stuff. It's a stack of techniques that ultimately get you to systems that are extremely reliable. It might be a less good poet than GPT-4, but if you tell it to do 10 things in order, it does those 10 things in order every single time. And this is what we're pushing for, is this reliability, this actually understanding of like, what is it doing step by step, and how can you compose these things? And this reliability is what unlocks this, is that the problem with current large language models is that they are not reliable. And if you tell even GPT-4, which is a fantastically smart model, to do like 5 non-trivial things, it will like 50% of the time get distracted by number 3 and like veer off or whatever. And it's just not predictable in what ways it will veer off. If you could predict ahead of time, it will veer off if I give it this prompt. That's also fine, but it's unpredictable. And so with cognitive relation systems, it becomes much more predictable. You get to actually, the system itself can detect when it won't know how to do things or when things will not go as planned. And this is what we've been working on now for quite a bit. And a lot of it's now starting to work, where we can get systems that can do, fundamental, basic tasks with perfect reliability. And so, truly like, up to measurement error, perfect. And you can then compose these things into larger, more complex tasks. So we're already starting to work with, first like enterprise customers and design partners here, because kind of like one of the reasons COAM is nice is because it's a good coordination mechanism. It's a good coordination shelling point because it is, I like to say, it's the kind of AI that companies want to buy. It's both addresses the control and the safety problem. Well, on the other hand, also, this is what most companies want. Most companies want an AI thing where you tell it to do something and it does that thing and nothing more. And it's boring and it does exactly what you tell it to do. They don't want a quirky brain in a jar with a personality disorder, which, we're seeing the resurgence of Sydney on Twitter right now. So this is what we built. And we're now open to some of our very first enterprise, design customers. If, anyone in the audience has a, large, company who has very high safety requirements, very high requirements for reliability, where maybe LLMs just don't cut it, and they want to try something new and something hopefully revolutionary, my emails are open.
Fantastic. Well, commercially, obviously, that has a lot of value. So I'm optimistic about you having a lot of success early on. In terms of control and AGI, however, if you predict, obviously predictability is better than not having predictability, but how do you still don't address the problem, I think, unless I'm wrong. You still don't address the problem if somebody wants to or sets out to, I don't know, start World War III.
Yes, this is a fantastic point, and it is exactly correct. So that's why I say we work on controllability, not on alignment. So if you build a COAM system, and so COAM as a technology scales to AGI. If we do this correctly, it is as smart as a human. It can do anything a human can do. And if you have a system that can do everything a human can do, including science, you have something incredibly powerful and something incredibly dangerous. COAM moves us from the regime of we are definitely fucked to it is possible to not be fucked. If this technology is misused by, say, terrorists, hostile governments, something, then we're screwed. And so this is why I say this is a compromised technology. It is an incredibly powerful technology that would allow you to have, digital, reliable human reasoning that you can scale. Imagine you could have scientists that follow proper scientific method and epistemology about any topic, any time of day, without ever getting distracted, in a way that is checkable, auditable, understandable, and you can rely on the results. If this works, if you do this, this is extremely powerful. It will allow you to develop extremely powerful technology. It will allow you to do incredible economic activity and so on. But it also means, of course, that you could use it for very nefarious purposes. If we get into a world where this technology has reached that level, and the world hasn't already ended for other reasons, we're in an unstable equilibrium. And this applies to any AGI complete technology. I think COAM is a compromise. In an ideal world, I wouldn't work on technology at all that is AGI complete, and we would work on, pure alignment tech or pure coordination tech. We don't have the time for that, and it's hard to coordinate around that. No one's going to pay you for that. The unfortunate truth is that doing research is extremely expensive. Doing lobbying is extremely expensive. Someone has to pay for that. The money has to come from somewhere. So it's a compromise. COAM is the least bad, the worst option that will work. It is, there are much better options, but this is the one that will work. This is the least bad that will work, I guess, is that it is much better than the current other approaches. The other approaches of just scaling up models and whatever just kill you once it's smart enough. It's just, and that's just it. This allows you to not die. but you also have to solve hard coordination problems of not letting this technology be abused, not letting it proliferate. If you make this open source, you're doomed.
Fantastic. Okay, how can people reach you or follow you?
You can follow me on Twitter at NPCollapse. You can also find me on various random podcasts. Also, my company website, conjecture.dev, or our nonprofit or controlai.com.
Fantastic. Connor, it's been an absolute honor to talk to you. You are a brilliant mind doing some really important work, and my heartfelt thanks for all of your effort and what you do. Thanks so much.
Thank you so much for having me.